So I will take the same example as given in lead code. So let's start with this first example. And I will just create individual indices as we are going to solve it using bottom-up approach. Would be nums I. So here is our nums I with each of the individual indices. So let's start with dp of 0. So as we know, the bottom-up paradigm is that we start with a base case first, and then we keep on moving to the higher cases, and we try to see whether we can reuse the results we have obtained from the previous subproblem. For example, when I'm calculating dp1, I will see that whether I can reuse whatever I have solved for dp0 already. And once we move to dp2, which will give me the final solution, we'll try to identify if there's any pattern or algorithm which we are observing while reusing the results of the previous subproblem, right? So let's start with dp0 first. So dp0 means that we are only given the first index only. Only one house is given with index 0 and having the money stashed as 2. Now, if we are given only one house, right, there are no neighbors to it, nothing is to it. So if a robber comes, he only has got one house to rob. So whatever the value is given, whatever the money is stashed in this house, that would be the maximum amount of money he can rob, right? So for the base condition, for only like one house available, whatever the value is given, that is our dp of 0. So here I will just mark it as dp of 0 would be 2, and this would be true for any type of inputs given. If we are only given like starting with the first index, the 0th index, it will always be the value which is given the nums of 0, right? So here is our dp for 0. Now let's go with dp of 1. Now we have got, for dp of 1, we have got these two houses available, right? Now let's see our conditions. So if I'm planning to rob this house, right, the first house or 0th index, it means that I cannot rob this house, right? I cannot rob this house because this is neighbor to it. So we have a choice. I mean, if I'm choosing only this house, the maximum value I can get is 2. So I will just write it down as, if I'm just choosing this, it should be max of 2. And similarly, let me change it. So before I put the second condition, now if I'm not planning to rob this house, then I have an option to rob this house, right? So if I'm planning to rob this house, it means that I cannot rob this house, right? Because it's adjacent to it. So that's why the condition is like very simple again. For dp1, if we are given the two houses only, we choose the maximum of these two values. So it would be just max of 2 and 3, and which gives me the result of 3 for dp1, right? Now let's go with our final solution for dp of 2. Now we have given 3 houses here for dp2, which is our final solution. So here, I mean, let's start that if I'm planning to rob this house, right, it means that I cannot rob this house, and I can only rob the houses which are before 3, right? Suppose, I mean, if I'm given like, I'm just giving an example that suppose there are like multiple houses here, like before 2 it was 1 and 3 or 4, right? There were like 3 houses before 2. So whatever the houses were there, we have already calculating the dp until this point, which is the index of this minus 2, right? So here it's whatever the value is there at this particular dp of this index, that would be taken plus the amount which is stored here, because we only cannot the rob the house which is adjacent to this house, to the house 2. So if we are choosing this, whatever is the neighbor to it is 3. We are unable to like rob this house because of the condition, because the security alert here in the neighbor, and 2 plus whatever has been the DP or at this particular index before all the houses here. So this is our first condition. So we have to take the maximum of 2 plus whatever has been the DP till this index, which means that I minus 2. Now the second condition would be that if I don't plan to rob this house, right? So it means that we have a choice that whatever the houses that we have calculated, whatever the DP that we have calculated till this point, because we can always choose to rob the house which is next to it, because we are not planning to rob this house. So whatever the DP has been here at this particular point, or we can say that index, if we are at index 2, whatever has been till DP of 1, so we can choose that result, and we have to see the maximum out of it. Maximum means that if we choose his house 2, then we have to choose whatever has been the maximum from 2 plus DP of I minus 2, till this point. And if we don't choose this house, then whatever the DP was there before this index that we are currently into. So better to write this in a formula. So the first condition was that if I'm planning to rob this house, right, in that case I can rob this house plus whatever was there before this index here, right? So from everything before 2 and beyond it. So it would be DP of here, because it's 0. So this is our first condition. Or better, I can write this as a formula. So it would be max of the nums I, because we are at index 2, DP of calculating DP 2. So our I is 2 here, and this is the value that we are having, plus DP of I minus 2, right? So this 2 plus DP I minus 2 is this, whatever it has been there before. Or the second condition is that if I'm not planning to rob this house at index that we are into, so whatever was the DP before this index, that is DP of I minus 1. DP of I minus 1, right? So here, if I just inject this formula, so it would be max of 2 plus max of 2, or 2 plus DP of I minus 2 is 0, and we've calculated DP of 0 is 2. So it would be 2 plus 2, and DP of 1, I minus 1 is 1. So DP of 1 is 3 here. So it would be 3, right? So here, the max is 4. So it would be giving me the answer of 4.